Hey guys, I got a homework question about number 24, and it's a particularly difficult problem, so I figured that I would make a video to help everyone out with it. It starts off as tangent of 2x minus 2 cosine of x equals 0. First thing you want to do is rewrite tangent of 2x as sine of 2x over cosine of 2x. Right, because tangent is sine divided by cosine. Then after that, you can use the double angle formulas for sine and cosine. So sine 2x is 2 cos x sine x. Cosine of 2x, we have three options. If you look around though, we have mostly cosines in the problem. So I'm going to go with the formula that has cosine in it, which is 2 cosine squared minus 1. Just bring down this minus 2 cosine. That still equals 0. Alright, next, I'm going to actually add this 2 cosine x over to the other side. And then I want to get rid of the fraction. Okay, so let's multiply both sides by the denominator. So we're going to multiply both sides of the equation by 2 cosine squared minus 1. So that cancels that out. So we have 2 cosine x sine x equals, over here we can distribute. So we get 4 cosine cubed minus 2 cosine. And at this point, well, every single term has a cosine in it, so you're thinking we can factor that out, right? But before we factor, we're going to want to get it equal to 0. So I'm going to take this term and subtract it over. So that gives us 0 is equal to 4 cosine cubed. I'm going to put this in the middle, minus 2 cosine x sine x minus 2 cosine x. Now if you look at this, I want to ask yourself, what common factor can we pull out? So I mentioned already that everything has a cosine, but in addition to that, if you look at the coefficients here, they are all divisible by 2. So I'm going to pull out a 2 cosine, right, which will leave us with 2. I only pulled 1 cosine out, so we'll have cosine squared minus sine x minus, well, I pulled 2 cosine out, so since we had a 2 cosine here, we're going to have a 1 left, right? We're really dividing when we factor out. Alrighty, so here we are. At this point, with it being factored and set equal to 0, we can separately set each factor equal to 0. So we have a really simple equation to solve here. This equation is not so simple and definitely will require a little bit more work. So because of that, I'm going to remember that this is here. And then go ahead and pull this one up here and keep working with it. Alright, so we move this one over here. We have 2 cosine squared minus sine minus 1. The big problem with this right now is that it has cosine and sine in it, right? It'd be great if we could get it down to having just one trig function. So is there a formula that will allow us to do that? The answer is yes. There is a formula, the Pythagorean identity. I can replace cosine squared with 1 minus sine squared. That's the Pythagorean identity. Bring down the minus sign. Minus 1 equals 0. Distribute, so we have 2 minus 2 sine squared minus sine minus 1. So we have, I'm going to put it in descending order. We have negative 2 sine squared minus sine. And then 2 minus 1, that's plus 1. All right, now let's make a substitution. Let's let u equal sine x. So that gives us negative 2u squared minus u plus 1 equals 0. Then we can solve this. It's always easier to solve if your leading term is not negative. So I'm going to go ahead and divide everything by negative 1, which gives us 2u squared plus u minus 1 equals 0. Now we should try to factor this. So it'll be 2u times u gives us 2u squared. I know I want to put a 1 and a 1 because the numbers we put here and here need to multiply to this. I know one of them has to be negative though, and one of them has to be positive. So I'm going to put a positive here and a minus there. So that way if you were to multiply it out, you would get 2u squared plus 2u minus 1u. That makes that minus 1. So it works. So we end up with 2u minus 1 equals 0 or u plus 1 equals 0. So here u would have to equal 1/2, and over here u would have to equal negative 1. All right, we made a lot of progress. We know that u is just a placeholder for sine, so actually we're solving where is sine equal to 1/2, and where is sine equal to negative 1. Okay, so I think on this problem we're only solving within 0 to 2 pi. So I'm going to circle these. Over here, if we divide by 2, we get that cosine has to equal 0. So these three equations need to be solved just within 0 to 2 pi. All right, so I'm going to leave that for you to do. You can find the solutions for these on the unit circle. So the very last step should be really easy. All right, thanks.